Hello, and welcome to the May 2020 edition of F5's Europe, Middle East, and Africa webinar series. I'm Marcus Sura. I'm F5's EMEA Corporate Comms Lead, and I'll be your facilitator for today's webinar focused on OWASP Top 10, the most critical risks facing web applications. So before we get started, just a few housekeeping items to note. You can adjust the size of the presentation box on your console by expanding the corners of the box. And you'll also find additional resources at the bottom of the screen by clicking on the widget icons. You may experience connectivity issues, and that's okay. Just try refreshing the console by pressing F5 if you're using a PC, or like me, if you're on a Mac, try Command+R. And if the problem persists, close the window and restart it. And also check the browser that you're using, and that might be the issue. If you have any questions throughout the presentation, just submit them in the Q&A box, and I'll take care of those, and we'll address them to David, who you'll meet in a few minutes at the end. We'll make as much time as possible for questions, because I know that's what you appreciate. And, you know, I think we should just start right now. So David Warburton is a senior threat research evangelist focusing on the Europe, Middle East, and Africa region here at F5. He's in the F5 Labs team, and he's going to be exploring how the OWASP Top 10 is resulting in a number of different vulnerabilities, and he's going to bring to life real-life attacks that have recently been exploited by OWASP Top 10 vulnerabilities. So over to you, David.
Great, thanks, Marcus. And don't worry about getting my name wrong. That's one thing I tend to do more often than most people myself, actually. So, right, let's crack on. We've got quite a bit to get through today. So welcome to everyone. Thanks for making the time to join us, as Marcus said. So we're going to get into the top 10, and we're going to look at things slightly differently than we have done in the past, just to try and mix up and add a bit more flavor and bring the top 10 to life a little bit more. But to put it in context, you know, why is this important? Well, we'll look in a second as to why the OWASP Foundation was created a number of years ago. But the average number of organizations have got around about 980 applications across their entire business. And that sounds like a big number. But when you factor in things like hosted SaaS applications, internal test and dev, and QA and pre-prod and so on, if we count each of those as separate applications, that number grows very, very rapidly. Now, what's surprising is how many of those are mission critical. If we had some live interactive poll, I might put it out to you to find out, you know, what you thought. But I will skip to the, you know, to the spoiler. We found in our surveys that around about a third of those 980 are mission critical. So around 300 of those are considered extremely important to the business. Now, what's worrying, I suppose, is that those mission critical apps are typically taken very seriously, and they have strong security policies which secure those apps, hopefully regardless of whether they, you know, where they live, whether they're on-prem, whether they're in the cloud. But what we typically find is that those other 600, those kind of poor forgotten children, the ones we don't feed and water or send to the best schools as our favorite kids, they are left to kind of run around and cause havoc. And quite often it's those applications, those non-mission critical apps, which can bite us. They're the ones, you know, the pre-prod environments that are left unsecured that can be found and exploited very, very easily and result in very damaging data breaches. Now, there are a number of ways of conducting a data breach, as I'm sure most of you are familiar with. Vulnerabilities in software is a primary source of those kind of attacks and data breaches. And the number of vulnerabilities we're seeing are going up almost exponentially, with the odd occasional drop in the number of CVEs reported per year. The CVEs are going up massively day by day. And what we've actually found as well, you know, analyzing the CVE data, is that the amount of time between high and critical CVEs being announced to the public has reduced to between 9 and 12 hours. Which is insane if we think about the number of vulnerabilities out there. Every 9 and 12 hours, one of those is critical or high severity. Now, when we kind of map that to our 980 plus applications, you know, clearly not every CVE is going to affect every one of us, but there's a good chance that, you know, a good percentage of them will do. And so just keeping track of those is extremely problematic. Now, the other problem is when vulnerabilities are announced and how they're used. You know, what we found is that this is looking at just 2019 attack traffic. So if we look at the red dots and all the instances of exploits being created for those vulnerabilities, and map them back. Clearly, we're seeing a large number of exploits being created, very rapidly after vulnerabilities are disclosed or released. So in 2019, there's almost 10 or so vulnerabilities of the more well-known ones that are very rapidly turned around and can be as quick as 1 to 2 days before vulnerabilities are weaponized. But we're still seeing attacks created by exploits that were released almost 2 decades ago. And really the problem here is that, we obviously don't, as an industry, have a great track record of patching things, keeping things up to date, and making sure that old software is patched or just removed from the service altogether. So before we get into the top 10, who are OWASP? Some of you may know, but they're an organization that have been around for almost 2 decades, founded in 2001, with the first top 10 released in 2003. And the reason it was produced was really to help board members understand the most common risks. Clearly businesses, they operate based on risk, but articulating that risk, particularly from a web application point of view. And if we go back to the early 2000s when these were first released, obviously we're in the middle of the dot-com boom where applications are being flung to the web left, right, and center with very, very little consideration put around security. So the top 10 was really put together as a way of educating not only the board, but also developers in terms of what are the most critical risks, what are the things we really, really need to get right before we start looking at those very, very specific edge cases of security. Now, it's not a compliance standard. There's nothing we can kind of, become that will help us become OWASP top 10 compliant. And there are many, many lists that the OWASP Foundation creates, including API vulnerabilities, mobile vulnerabilities, and so on. But the top 10 web app is certainly one of the most well-known, and certainly one of the more useful kind of frameworks that we see in the industry. Now, what we tried to do in the top 10, what we found is there's quite a lot of overlap, really, between the top 10 vulnerabilities. And also, I found that we could kind of group them fairly easily. So what we've done is we've grouped these vulnerabilities to really show the kind of overlap and just the severity of the problem that we've got. So we'll dive straight into it. And the first one really all comes down to some form of injection attack, some problem which is caused by trusting data that the user's sending to us, to our web application. There's a number of different ways that this can happen through databases, through operating systems, through commands, and so on. But generally, the problem is all to do with interpreters. So many of our applications, many of our kind of frameworks and apps take some user data and try and interpret it to figure out what is meant by that. We might get a string, and is it a number? Is it a character? Is it metadata? All these things like PDF renderers and image renderers and web apps which accept data input all interpret that data. And when you come down to interpretation, things can go very, very wrong. So remaining at the #1 spot for the past couple of years, it was number 6 when the top 10 was first released in 2003, remained at #1 for a while, is injection. What we've also tried to do is take how the OWASP Foundation have kind of categorized these various vulnerabilities in terms of their exploitability, their prevalence, so how often they're found in the wild, how easy they are to detect, and then ultimately the kind of technical impact to that if it were to be exploited and used in some kind of attack. So clearly we can see just from the little speedometers that we've created that actually this is a pretty serious vulnerability, and it's somewhat of a catch-all. Injections can affect lots and lots of different systems, like I said, from SQL or SQL databases and even NoSQL databases. There are command injection, log injections, but typically we see it in web apps when we're accepting kind of user data through some kind of form or through some kind of parameter, and the web app is blindly trusting that and sending it to a back-end database system, which is trying to interpret that user data and ultimately and unwittingly executing some kind of command on the back end. So this can lead to anything from data loss, corruption of service, and even full remote code execution. And clearly, if we can execute arbitrary code on a remote host, then there's very little that we potentially can't do to that system and to the data. In terms of real-life instances, we wanted to look at, how are these attacks actually being exploited in the wild? Now we have, protected the names to, or hidden the names to protect the innocent. But there have been some very, very well-known kind of cases over the past few years. Certainly here in the UK, there was a very big ISP or telecom provider a few years ago that leaked 150,000 customer records, and that was a very basic SQL injection attack. And in fact, a number of reports kind of chastised them for the simplicity of the attack and the lack of controls that were in place to protect against it. So how do we protect against injection? Again, this is a bit of a catch-all category, but generally speaking, we want to separate the user-supplied data from the commands and queries that we're running at the back end. There are a few ways of doing it. We can use safe APIs. Ultimately, we always want to kind of filter or escape the user input before we even, try and execute it or send it to a database at the back, for example. On top of that, again, a lot of security is defense in depth. So as well as escaping input and checking, validating user input, we can also do things on the database side in terms of just limiting the number of records that are returned and maybe limiting the number of queries that can be performed by any one user at a time. Clearly, even if we kind of miss some kind of injection attack, it's better to limit how many records can be returned instead of leaking the entire database. If we can limit it to tens or hundreds, that's clearly going to be a less of an impact than it would be from leaking millions of records. So the next one, again, you'll see we've jumped on to number 4 on the list because we're grouping this by kind of category. So XML, external entity, or XXE attacks are another form of injection attacks. The key here is that older XML parsers, particularly those running on SOAP 1.2, allow external entity referencing. What that means is if an attacker can send an XML payload to an XML interpreter with a reference to a file, that file may be accessed and returned to the attacker. The example we've got here in blue on the right is the attacker submitting an XML payload, and in that he's referencing the password file on a Linux system. And again, without the right kind of protection, that could potentially send the password file to that attacker, which allows them to brute force it offline. So generally speaking, many XML processes are vulnerable, particularly, as I said, if you're running on SOAP 1.2 or earlier. Now, in terms of real-life kind of impacts, again, there've been a number. This is a newer vulnerability, I would say. It's certainly new to the top 10 this year. In fact, if we look at the exploit database, very kind of useful site to see how vulnerabilities are actually being weaponized. There's really no evidence of XML XXE attacks on there from before 2017. So it's very new, but potentially very damaging because, again, it could leak data, it could even be used to perform remote code execution. In terms of mitigating it, probably the biggest thing you can do is to educate and train developers in terms of preventing that external entity reference altogether. If that can't be done, upgrading SOAP to a newer version than 1.2 is strongly recommended. But also looking at different data formats. Now, generally the developer preference is to use file formats such as JSON. And while that has its own problems in terms of potentially injecting malicious data, it's clearly easier to parse that data than it is to send it to some kind of interpreter at the back end. So we jump into number 7, still talking about injection attacks. Cross-site scripting, many of you will have heard of this. It's yet another form of injection attacks. Essentially, the concept being that an attacker can send a malicious code to the vulnerable web server, which then effectively plays it back or renders it in the client browser. The number of different forms of cross-site scripting attacks are reflected, where the malicious code is immediately rendered on the client browser or the victim's browser. It can be stored, where that malicious code is actually just held in a database, and then potentially, from an impact point of view, can be much worse, because if it's stored in some kind of record which is then rendered or shown to multiple users, you could potentially infect or grab the details of thousands or millions of customers. And then document object model XSS attacks affect the more kind of API or single page applications that are becoming more prevalent. So there's 3 different forms, all generally work on the same principle. The problem being, again, where the attacker is allowed to inject arbitrary data or commands into an input. That can lead everything from session hijacking. So basically the attack is stealing a validated user session. So if I'm logged in, for example, an attacker performs a cross-site scripting attack on me, they could take my cookie, they could take my session ID, and then use that to impersonate me, take my data, make changes, and if I'm an administrator on a system, potentially take that system down and wreak all sorts of havoc. Now, it's interesting, while cross-site request forgery isn't on the top 10 in the 2017 list, it is still an issue, and actually cross-site scripting can be used to defeat a lot of cross-site request forgery defenses. So it's cross-site scripting, although it's kind of dropped a few places in recent years. As I said, it's number 7 on the list. If you look at the speedometers we've got in the severity, the prevalence and exploitability is extreme. Very, very easy to detect in the wild and very, very easy to carry out. So a number of significant victims that have been hit by cross-site scripting. Everything, as you can see, from the breaches that range from the hundreds of thousands to the millions of records. In fact, we had one of our own security researchers in the F5 Labs team that found a cross-site scripting vulnerability in the Microsoft Android app only last year, I believe it was, and worked with Microsoft to get that fixed. And in fact, if we look at just the number of vulnerabilities, we saw just over 1,000, about 1,100 CVEs registered in 2013 for cross-site scripting. That has declined. That's only now down to about 500 for 2019, which I think is why it's dropped a few places in the top 10 list. But again, if you look at the impact this can have and how prevalent it still is in the wild, it's still a very significant concern for a lot of people. So, like most of the injection attacks, in terms of preventing it, really we need to completely separate, or as much as possible, separate the untrusted user data from the active browser content. Now, this is getting slightly easier. There are frameworks that we can use. There's Rust, there's React.js that will help escape input and validate input when it's coming in from parameters or form objects. But really, this should be just front and foremost of every developer's mind is escaping input. So basically surrounding certain meta characters like commas and question marks and other meta characters which are used in things like SQL query languages to make sure that if that does get to the backend database, that doesn't get interpreted by the database to perform some kind of action. From a defense in depth point of view, again, whilst we want to train developers and use things like secure frameworks and possibly look at web app firewalls, there are still things we can do with regard to secure headers. So using things like CSP can just add another layer of defense. CSP is a header that will get injected into the web app, which can very, very strongly restricts where scripts and other resources can be loaded from. So what that means, it basically prevents cross-site scripting attacks referencing scripts and resources that reside on an attacker-controlled domain. Insecure deserialization is new this year, I believe. And again, it's another form of injection, which is why we're still in this kind of category of not trusting user data. The problem we've got here, and why this stands out as its own discrete category, because again, you'll see a number of kind of overlapping items in the top 10. But why this stands alone is because it's new, so it's come to the fore, and really because of how the data is treated. Whereas most kind of web app parameters and form objects are seen as discrete elements that can be read and maybe protected against by things like web app firewalls. Typically with when serialization is used, we're treating that data, we're treating that user data as a blob, as like an object, which is just thrown straight to the web app, and it's left down to the web app to kind of interpret that and figure out how to use it. So what that generally means is these security controls that we've got inline, web app firewalls and the like, typically aren't able to or don't inspect this object. So similar concept. The example we've got here is that the attackers very, very simply kind of changing the privilege of a user in the object that's being sent to the backend web application. And if that's not checking that properly, if there's broken authentication or authorization, then potentially they could elevate their privilege and start conducting admin level kind of attacks and even gain things like remote code execution. The example here is just one from earlier this year, actually, a remote code execution that was achieved by performing deserialization attack against Microsoft Exchange. So clearly, even a large kind of enterprise, widely used app like Exchange is still vulnerable to this kind of attack. In terms of protection, as the OWASP frame, the OWASP Foundation themselves recommend, really try not to use serialized objects from untrusted sources. So, where possible, don't let the user supply serialized data. Where you have to perform integrity checks, maybe signature checking on the objects, isolate the code that's running. So if there is some backend code which is interpreting that object, try and isolate it as much as possible to really minimize the damage it can do, limit its database privileges and so on. And check for things like invalid meta characters. So really, the problem we've got with deserialization is a lot of that logic and protection needs to be put into the actual web app itself on the back end. So we're going to shift into our kind of next category, let the right one in. What do we mean by that? Well, attacks are generally multifaceted. It's very rare that we'll get a successful data breach that's just through exploiting one particular vulnerability or one particular attack type. And what we see is increasingly authentication-based attacks are quite often the first point of call or used somewhere in the attack chain. Quite often it will be a phishing attack which kicks off an attack campaign, which then maybe gains some basic level credentials to log into Active Directory. And then once the attack is in there with basic user credentials, they can then exploit a vulnerability in some command or operating system or API inside that network. So attacks are multifaceted and multi-layered, and as I said, authentication is playing an increasing part in the attacker's toolkit. So, and you'll notice this, so we're actually back up at sort of number 2 in terms of the top 10 now, broken authentication. Broken authentication is, again, very much a kind of catch-all term for anything where we're not sufficiently checking the credentials or protecting the abuse or reuse of credentials. So broken authentication can cover everything from brute force attacks, which are effectively like password guessing, to credential stuffing, where attackers have databases of millions of known valid credentials, and they will try those against different web services to see which ones gain them access. Session hijacking and session fixation are generally the same thing here. There are many sites, some which are still being used, again, very widely today, where you might see a session ID in the URL. So we'll get a big, long kind of URL in the address bar, and part of the parameter will be a session ID. And that's how the web server identifies it as me after I've logged in. Well, if that's not checked correctly, someone could copy the URL or intercept or somehow otherwise grab my session, and simply by submitting that session ID to the backend web service, automatically gain authentication and access to the system as if it was me logging into that system. So although the prevalence isn't as high, again, you'll notice a lot of these technical impacts are very, very high. Some of them are hard to, some of these vulnerabilities are very difficult to exploit. Some are very easy. A lot of them have very high technical impacts. So let's jump into prevention. Again, there's a number of examples there on the left that I will let you scan through. In terms of prevention, there's a number of things we can do. Probably first and foremost, one of the best and easiest things you can do is multi-factor authentication. Clearly, we need to try and educate users to not reuse passwords. We need to try and have systems in place that prevent the use of very weak passwords. Ultimately, that's probably still going to happen, though. And even if people are using different passwords at different sites, there's always a chance that that password can be grabbed through some phishing attempt. So having another layer, so multi-factor authentication, like a hard token or an app on a mobile phone, or even a text message, can add a significant barrier of entry for attackers looking to reuse credentials. But secondly, I would probably say right after multi-factor is actually detecting who is logging in. Because the vast majority of access-based attacks are conducted not by humans sat behind keyboards, but they're by scripts and bots. Quite often that are being run from compromised IoT devices and web servers all over the globe. So if we can detect who is logging in, the type of user, whether they are human, whether it's a bot, and if it's a bot, is it a legitimate bot that's allowed to perform this action, that can massively cut down the amount of malicious login attempts that we have to deal with. Additional things we can do will be making secure use of things like session ID, and also making sure we're storing passwords securely. One of the categories, if you like, that's covered under broken authentication is the theft of password databases. And still, there are so many password databases that aren't secured properly. They're either using encryption instead of hashing, they're maybe not secured at all, or the keys for that encrypted database are kind of left alongside it, so they're easy to grab to allow the attacker to decrypt it. Sensitive data exposure is, again, somewhat of a kind of catch-all term. This really specifically is more often than not talking around the use of encryption. Now, we're doing a great job at encrypting the web. The average amount of encrypted web traffic is now up to 86% of all pages that fly across between browsers and web servers. So we've done significant improvement over years, but there are still pages that are being loaded unencrypted. Not all sites protect every one of their pages or APIs with encryption. And those that do use encryption sometimes don't get it right. They kind of, deploy old ciphers, old protocols, or generally don't secure things properly. So sensitive data exposure here is really referencing the lack of or poor use of encryption. In terms of prevention, there are a number of recommendations. In fact, our recent TLS telemetry report goes into the kind of weak use of encryption, the weak use of ciphers out there, how many of the top 1 million sites are using poor kind of TLS encryption, as well as provide some good recommendations. But really, this comes down to good crypto management and good key management. And like everything, a lot of that is keeping things up to date. It's making sure that protocols are up to date. You're adhering to kind of best practices for the best protocols and ciphers to use. And also making sure that you're keeping the keys safe. Because if you leave the private keys lying around on a database, or sorry, on a web server, then some other obscure and unrelated vulnerability will allow the attacker to log in, grab the key, decrypt the database or decrypt the communications as they go. So generally, this is follow best practice guidelines. There are compliance standards, things like NIST and HIPAA, which enforce certain levels of encryption and protocols to be used. So certainly if you're in one of those industries, whether it be finance or health, that is affected, then certainly making sure that you comply with those standards would be a good, very much a good first step. Broken access control is at number 5, again, under this concept of authentication. So we're not talking around broken authentication here, but broken access control. So this might be where a web server has successfully authenticated you once, but then doesn't keep checking those valid session IDs or valid credentials for every action that you take. So what this means is we could start performing URL tampering. Just because I've authenticated doesn't mean I'm necessarily authorized to go and look at a certain page. So if I successfully authenticate once, I can then potentially change the URL or parameter to maybe get access to a system that I shouldn't be allowed to. This ultimately leads to things like user impersonation and privilege escalation, where again, if I'm able to impersonate some kind of admin potentially, then I could completely wreak havoc. I could encrypt things with malware or ransomware. I could destroy databases or steal databases and information. As I said, Amazon has 3 buckets. We'll probably mention a few times today. They fall into lots of different categories. The number of breaches just over the past few years that have occurred due to broken access control, due to S3 buckets, is pretty alarming. Now, clearly, there's nothing wrong with the systems in place at AWS to authenticate users. But when things aren't checked, or when databases are cloned and maybe the right authentication methods aren't copied between pre-production and QA and live, then these kind of things can leak potentially entire databases at a time. So the thing to consider with broken access control is there are very much some technical limits you can put in place. Clearly, one of the most key principles of security is least privilege or deny by default. So really, locking everything down and only allowing access to those users and those actions that they need to have access to. Additional technical limits might include things like rate limiting, particularly when it comes to APIs. But actually, I would say, a lot of this is business logic, and it really takes that kind of human and process kind of element to really determine who should have access to what. So less of a technical control, I would say, than some other vulnerabilities in the top 10. This really needs to be everyone working together to really determine, who should have access to what, at what time, and under what conditions. So the remaining 3 or 4 items we've got in the top 10, I figured all came under some kind of, to me, they all struck a chord in terms of they're just the basics that we continue to get wrong. They are things that should be fairly easy to remediate and fix. Again, they're basics, but quite often the basics get missed for various reasons. It could be due to time constraints, resource constraints, or maybe just a misunderstanding. Frequently we still see applications move to the cloud with the assumption that things are secure by default in the cloud, and not realizing that obviously there's different responsibilities and different ways of securing those. So another somewhat kind of general kind of vulnerability, if you like, is security misconfiguration, which, as you can see, can lead to everything from brute force attacks to code injection, cross-site scripting, and false browsing. So security misconfiguration can be a result of anything from not removing, default user accounts to not blocking weak or default passwords. It could even be, again, by default, allowing directory browsing on your web server. If you allow directory browsing by default, that allows the attacker a lot of information to kind of gather, to look for old configuration files, to look for backup files, and other things that'll help them conduct an exploit, successful exploit against that web application. Now, security misconfigurations can affect everything, not just web servers. It can affect database servers, frameworks, even password reset mechanisms can be included. Generally, I think as an industry, we're getting better at password resets. We still see the odd number where you could log into a website or attempt to log in, having forgotten your password, hit the reset button, and lo and behold, you get your clear text password in the email sent to you, which is clearly a no-no, because it means the password being stored, very likely being stored in the clear in the database. So security misconfiguration can apply to lots of different areas as well as the web server. I think 2 of the most important things we can do here is having a hardened template, hardened baseline that is applied not only to our live and production apps and web applications, but to all applications, regardless of where they reside and whether they are live or pre-prod or QA or test or whatever. Because clearly we need to make sure that we have consistent security across the board. If we just assume that things will be secure once we throw it over the fence into a production environment, then there's a very, very good chance that things will be missed. Part of what can really help here is really integrating security into the DevOps kind of lifecycle or CI/CD pipeline. Clearly, if we're testing code, testing our controls and defenses as we roll out and test new features, then we're going to be in a much, much better position than if we develop our code, throw it over the fence, and just test it once it's live or once it's in the kind of final resting state. So number 9, using components with known vulnerabilities. Now, detectability and technical impact might be slightly lower, but prevalence is way up. And why is that? Well, increasingly we're using more and more third-party libraries, frameworks. We're reusing code, whether it's open source or closed source libraries, for use in our own applications. Why would you reinvent the wheel if someone's done the hard work for you and you can just dynamically or statically link to that code? So whilst it massively improves, feature set and performance and speed of delivery for applications, clearly what that means is if a library or framework is discovered to have a vulnerability, it's not going to affect just one application. It's going to affect everyone that's using that library or framework. JQ and WebMin are 2 that we've kind of pointed to below. They've affected millions and millions of customers just over the past few years, just through one vulnerability each. Because again, whether it's a hosted platform or a library that you're statically importing, vulnerabilities, as we said at the top, are being announced all the time. And unless we're keeping a really close eye on all the libraries and all the dependencies we've got to make sure that we're patching and updating those all the time and making sure that those patches don't break some other kind of dependency, then we could be in a really bad place. And this is why it's such a problem, why it's in the top 10, is that because of increased use of libraries, it's getting more and more difficult to really keep track of what libraries are vulnerable and making sure that we're patching them when we need to. So one example now we've given was from jQuery, a specific CVE that got mentioned. Again, I would say this is both a technical and non-technical matter to fix. Clearly we need processes and procedures in place to make sure that we have a method of checking which libraries we're using which have updates, which have got known vulnerabilities, you know, making sure that we're alerted to those and patching them when we can. And clearly that's going to be easier if we have some kind of DevOps development methodology where patches can be integrated, you know, applied, integrated, and tested far more frequently than we have to just, you know, test it after the fact, after we go live, which again may result in some kind of broken application if we've updated a dependency, which then breaks some other library that we're using. And we've made it to the top 10. So number 10 on the list is insufficient logging and monitoring. Clearly, this isn't a vulnerability in the app itself, but what we see a number of reports from different vendors, different industries that show the length of time that attackers can be embedded into a network, into an organization before they're detected. I think the average time is around about 120 odd days before a breach is detected, which is insane. If we think about it, the amount of damage that could be done in 120 days is enormous, from deploying ransomware to stealing data to corruption, taking down entire services. But not only do we have the problem where insufficient logging will mean that we're potentially blind to what's going on, it also means that when it comes time to determining the impact, maybe, certainly under GDPR, one of the big requirements of GDPR is knowing where you stand in terms of how a breach has affected you and how it affects the privacy of your customers. Well, if we don't have the logging in place to really understand how an attack was conducted and where the attacker roamed the network, what they did, then clearly we can't comply with that. We can't tell our users and the data protection authorities the significance or the extremity that the attackers went to and the data that they impacted. So I mentioned, what could happen. Clearly, it's logging that we need, and it's everything from the web app side of things to our security controls and devices, and really most critically, it's logging attempts and failed parameter validation attempts. So anytime, I would say, and essentially we're talking about injection here. So anytime any kind of injection attack is potentially spotted, obviously that needs to be logged and it needs to be alerted. But I would say on top of that, most critically, is making sure that we've got a way of analyzing reporting from our logs that span multiple systems. Clearly, a number of our security devices have strong logging in place, but if we have to query each one of those independently, then it's going to mean that we're not, not reporting on things efficiently. So 600 applications that are deemed non-mission critical. All of those are very, very likely not getting the security in place to protect against the top 10 that our mission critical applications are. So what do we mean by protect every app? Well, we've covered a number of different ways that applications can be attacked. And certainly this is changing, day by day. We've got serverless applications, just APIs effectively being presented and exploding all over the place. We've got containers, we've got different places to deploy applications. And we've got to consider how third-party libraries and hosted applications are secured, because quite often they're out of our direct control. So the risk service, I would say, is growing massively for our web, for any application that we're managing and using within an application. So whilst a lot of the things we need to do are people and process-based, clearly there are some things we can do technically. One of the things that I think would be a great place to start is F5's new Essential App Protect service. So this is essentially a hosted and managed web application firewall service that is fully hosted, fully managed for you. It's friendly, it's kind of DevOps friendly, as we call it. And really what we mean by that is it's fully API driven. So while we've got some very nice dashboards and it's very easy to use and report through your traditional web user interface, actually all that can be bypassed and accessed directly through APIs. The great thing is, because it can protect any publicly hosted web application, because it's very simple to deploy, very simple to manage, it's perfect for for protecting all of those applications, particularly the ones that don't get the time, attention, or money that potentially could be spent on them because they're deemed non-mission critical. So this is a really quick look at that web interface that I mentioned. Again, it's something that could be bypassed if your developers are accessing this via API. I think what's great is just the level of visibility you get here. So we've got a very quick look at where attacks are originating from. We can see how genuine user traffic compares to malicious user traffic and how that's compared over time. And we can see the different types of applications that are blocking and any events that we might want to drill down into. So if we drill into events, there are various ways as well that we can actually help protect and mitigate threats, certainly mitigate, attacks that are conducted from, that will be covered under the OWASP top 10. There's a number of signatures that will get applied that can help block malicious attacks. You can see which ones are deployed, which ones are being placed into enforcement to actually block those attacks. We also use things like malicious IP databases. So we could potentially choose to just completely block access to an IP that we deem far too risky. And certainly there are some IPs that we might want to consider allowing access to, but some that we've guaranteed through very high probability are an infected device or a malicious user. Then again, it's about minimizing that risk, cutting down the number of specific incidents we need to look into manually, so we could block entire categories of malicious IPs there. As I said, we can drill into specific events, and we can also make use of what we call threat campaigns. So these are very, very targeted, very specific signatures, which are very accurate, very high performance, and protect known vulnerabilities against applications that you might have deployed. So at a super high level, what does it look like? Essentially, you will start by configuring your DNS CNAME record to redirect and point the public IP address of your web app to the essential app protect service. This will send the web app to the most kind of efficient data center. So we'll have various instances all over the world to make sure you get high response and high performance. That goes through the essential app protect engine to read not only the requests coming in, but the response going out to secure it and make sure that we protect all of your applications. And as I mentioned very briefly in the previous slide, we've got the threat campaigns feed. Now, they are a very specific and targeted set of signatures that our researchers, through the use of proactive security research, through the large sensor network that we have that collected active attack traffic, we can very, very rapidly spot live attack campaigns as they're occurring. And then very rapidly deploy threat campaign signatures either to your on-prem F5 or to this hosted F5 Essential App Protect service. So before we wrap up, I thought it might be fun to kind of look at maybe some predictions. Now, what you might have been expecting me to mention is the OWASP Top 10 2020 list, but the OWASP group mentioned a few weeks back that's largely in part because of various kind of lockdowns and the impact of COVID-19. That's going to be released later this year, so we haven't got it yet. So what are we expecting to kind of see? Well, actually, the top 10 doesn't change drastically over the years between the 3 or 4 year intervals that it's typically released over. Clearly, I definitely think injection is going to remain either at number 1 or go very, certainly is going to stay very, very high up there. What I do think will drive up massively will be authentication and authentication-based attacks. Again, the sheer prevalence of breaches from Amazon S3 buckets or open databases through phishing attempts and other kind of poorly secured web apps mean that it's frequently the number 1 method of attack for threat actors. But also it's worth kind of looking out for other things that I think might be included in the coming year. Form jacking is something we're talking a lot about within F5 Labs because we've seen so much of it over the past year or so. It's largely affecting retail, but it's also spreading to affect finance, online kind of grocery shopping, and really anyone that takes any kind of credentials or financial payment data from users is potentially a victim or a target, I should say, of form jacking. Now, while form jacking is yet another form of injection, I think what's different about it is quite often the form jacking attack can occur directly in the browser. So outside of those typical controls that we've got within our data center perimeter. There are methods for protecting against those. It's not easy. So it wouldn't surprise me to see form jacking or some type of form jacking vulnerability mentioned in the new top 10. And with so many libraries and scripts being hosted and dynamically linked to over the web, again, a super easy method of attack for, if it's a targeted attack against a particular organization or even a blanket attack. If a threat actor can compromise a GitHub account through a phishing attack, he can potentially update a GitHub repo with malicious code and affect thousands or hundreds of thousands of users at a time. So those kind of hosted resources, those scripts, those libraries, those JavaScript objects which are hosted on OpenS3 buckets, I think could be, definitely a growing concern, and wouldn't surprise me to see those in the top 10 later on this year either. So key takeaways from the top 10, how can we kind of summarize this and what can we do? Well, really, as I said, there's very little that's changed over the past 15 years or so, almost 20 years now. There are some of the vulnerabilities that have kind of dropped out of the top 10. Some are new, like insecure deserialization, for example, and others have been combined. But clearly there's a lesson to be learned here, is that really a lot of the same vulnerabilities continue to affect us. So we're clearly not doing a great job at kind of learning our lesson. And I would say, again, this is largely in part down to those non-mission critical apps. I think we are doing a better job of really protecting and securing our mission critical ones, but it's those poor, forgotten, long lost relatives that we really need to pay maybe better attention to. Increasingly, NetOps and DevOps are playing a bigger part in deploying their own security policies. Sometimes that's for good, sometimes that's for bad. Potentially, if it's not integrated properly, or they're not fully aware of vulnerabilities or what the controls are doing. But clearly, just being aware that there are many, many different people now that are deploying applications themselves and the security policies on top of those, and really making sure that there's a framework inside the organization to work with those, make sure that everyone's working together in a very kind of agile and DevOps methodology. Defense in depth, it's nothing new from a security perspective, but clearly there are things we can do here, both from a physical technical control, such as web app firewalling, to improving code using security headers like CSP or HTTP strict transport security, as well as educating developers and just raising awareness in as a whole. So this isn't a kind of one-stop shop. There's no silver bullet to fixing a lot of these problems. It's a case of really working holistically to make sure we approach things from different angles and really applying defense in depth. WAF, we've covered WAF. Clearly, WAF can protect against the majority of top 10 vulnerabilities and certainly help with all of them. But I think the key isn't just deploy WAF, it's deploy WAF everywhere. Even if it's something that you're very cautious about and don't have a lot of experience of, that's clearly perfect for something like the F5 Essential App Protect, where it's fully managed and fully hosted for you. But if and above everything else, it provides a huge amount of visibility that quite often you just don't get with internal logging for those systems. And layer 8, as we kind of jokingly call it, the human factor. It's those basic misconfigurations and mistakes that are made, leaving defaults in security misconfigurations. And really that is nothing simple to fix. That's through training and awareness, and having a really strong, robust security policy and awareness. So I think we finally got through to the end of the top 10. I'll hand back to you, Marcus.
Thanks, David. Well, we've had a number of questions come in, and the first ones, I'm going to bring them all together, are relate to testing. So, David, how would you test for the top 10 is one of the questions we've had. And then, is there a recommendation for OWASP ZAP to test various vulnerabilities? Yeah,
so yes, some very good questions. There are a number of methods of testing, scanning for these kind of vulnerabilities. A lot of them can be detected through things like dynamic application security testing or static code analysis, so DAST or SAS tools. Static code analysis tools will, as the name suggests, look at the code, the raw source code, to try and figure out if there are injection attacks. And actually, that's a really good place to look for any kind of injection attack is actually in the code. Sometimes vulnerabilities are really only obvious once they're deployed in a live production environment, and that's where dynamic testing comes in. So that will look to scan and test live code or live applications as they're deployed. That has a benefit of looking, querying for known vulnerabilities. So quite often these tools will be able to detect libraries that are in use, the versions of those libraries, and that can then map it against known CVEs and known exploits to really highlight and bring up to the fore which of those vulnerabilities you should really look at first. And I thought I'd remembered the second part of that question, Marcus, but it's just escaped me.
Yeah, it's just around specific tools. So the one tool was around ZAP.
ZAP. Sure.
Yeah.
Yeah, absolutely. And so OWASP, again, we've mentioned a few of the top 10s, a few of the lists that OWASP create, but they also have projects and tools. ZAP is one. So ZAP is very much like Burp Suite for anyone that's used that or is aware of it. It's a way of, as a security tester, I can send all of my traffic through this proxy, whether it's Burp, whether it's Zap or similar tool. That allows me to then see very clearly not only what's being sent between my client, my web browser, and the web server, but also allow me to manipulate it. So I could test for things like URL tampering. I could try changing cookie values. I could try changing parameters and see how the web server responds. An extension of that will be to use things like a fuzzer, which again is available in Zap and Burp Suite. And fuzzing is where I can go and try and tamper with a parameter to maybe change my user level permissions to an admin. But quite often problems are only found when you just throw an absolute ton of data in all different permutations at the web server and see how it responds. So quite often it's not an obvious thing to spot. Quite often these things are to do with the kind of very internal code of a web server and how it interprets things. And they're quite often only exposed through things like fuzzing. So I would say Zap is definitely something to use and look at. Although I would say it's something you probably want experience and training with, because it would be quite easy to use it yourself. And if you're inexperienced, scan a website and assume it looks kind of clean and free of problems.
Great, David. We've had a few questions around APIs, so I'll ask these in the next few seconds. The one is, okay, do APIs generally have bad security? Is one of the questions.
I mean, the OWASP have their own top 10 for APIs, which probably says enough in and of itself. What we found through experience at F5 and in F5 Labs is that APIs generally have much less security. It's almost like any new technology that comes along. APIs certainly aren't new, but they're a lot more popular than they used to be. Containers and certainly serverless, I could apply and say the same thing to. We seem to learn fairly good lessons from our traditional technologies and protocols, and don't seem to automatically carry those lessons learned through to newer protocols and technologies. APIs being a perfect example. So a lot of APIs, aren't secured properly. They're not rate limited. They don't have the same kind of content or parameter inspection that a standard user kind of web interface would do. So I would say yes, APIs, and that's why I put in my predictions maybe for the coming 2020 list is although they have their own top 10 lists, I wouldn't surprise me to see APIs mentioned specifically in the more general web app top 10.
Great. So, David, we're going to try and get through at least 5 more questions in the 10 or 15 minutes we've got left. So, try and keep them short and sharp. So, I want to get through as many as we can. This next one is around APIs and specifically around F5 cloud services. The question is, how can I protect publishing APIs through F5 cloud services?
They are available through. I mean, I will preface this kind of answer by saying I'm not a kind of product or solution expert. That's something that's worth getting in touch with the sales team about. There are a number of ways of protecting APIs public-facing through F5 services, whether it's something through like Essential App Protect or whether it's through Silverline, our cloud and managed service. There are definitely ways and means of doing that. So, but again, I would recommend you get in touch with your sales team for that.
Great. So, David, this question came in while you were talking about cross-site scripting, so a while ago. And the question is, when you mentioned the word stored, does the attacker plant a malicious script on the web page? And so does that mean when the user is browsing that web page that their payloads are executed and then sending information back to the attacker? And if so, how does this work?
Yeah, effectively, and this is something I could spend loads of time on, and clearly from what Marcus has just said, I should probably keep it brief. But essentially, it's the malicious code is sent to the database and stored such that when the user visits or any user visits a page, it's rendered. A good example might be a open user forum or like a guest book, as we used to call it decades ago. So I could, anyone could go and submit maybe a review of an item, or they could submit an image or something like this. If that then contains malicious code, which is then stored in the database, every time someone goes to see a list of reviews for this object, that text and malicious code will be sent back to anyone that views the page and be executed in that victim's browser.
Great. Okay. So a number of other questions coming in. One is around SQL injection. It's really more of a comment. It says it's been #1 for a long time now, right?
Injection as a whole has been, yeah, and I think this is what's interesting. If we look at the The top 10, as we've kind of tried to do in our categorization and our grouping, there's a number of different types of injection attacks. SQL injection is definitely one of the most prevalent. If you go to exploit.db, so exploit-db.com, and just search for injection, it will return every time of exploit which uses an injection, but the vast majority of those are SQL injection attacks. There's still a huge number that are being, vulnerabilities that are being weaponized into attacks.
The next set of questions are around WAF. So how protecting the app via OWASP dashboard, how would that be helpful for a WAF?
I am going to be honest, I'm not familiar what is meant by the OWASP dashboard. Let me have a think.
Maybe it's the principles. Maybe it's the
I'm
principles.
going to interpret this. Sure, I'll go into it, and I might please correct me if I'm wrong. So what we can do in web app firewalls and other controls is to potentially kind of flag, web apps or ports or services that we're protecting through that WAF as quote-unquote compliant with the top 10. And I use that term very, very loosely because, again, we can't be compliant. But we can certainly highlight which ones we believe are vulnerable. So we could provide things like a red, amber, green, or RAG status for the applications or services that we're publishing. I would say it's a helpful additional kind of defense in depth. It's another checklist to make sure, point to make sure that we're applying the right controls. But I would say if we're relying on some kind of dashboard in a WAF to show us what we're vulnerable to, it's going to help, but it's certainly not going to reveal everything. That's something we really need to go to source. And again, it's code analysis, it's dynamic, application security testing and processes in place.
Great. A number of other questions. So this one's, again, you might not be the product expert, but we'll ask some of these questions anyway, and we can always then connect people with the right people. Is F5 Essential App Protect available for on-premise?
It's not. It's a hosted service, which is both a benefit and to some people, they might prefer to run it on-prem. Typically, what I think we've positioned Essential App Protect for, who we positioned for, are those that don't have experience running web app firewalls or don't have experience with vulnerabilities, that certainly, and that's predominantly going to apply, I would say, to non-mission critical apps. Certainly Essential App Protect could protect mission critical applications, but I would say for those, a lot of people want the finesse and the control you get from running your own instance. And so in that case, that's where we recommend running either some physical or virtual F5 appliances, even Shape and Nginx appliances on-prem that can absolutely provide the same level of control, but to the nth degree, that provides you much more flexibility and granularity for protecting very specific applications.
And David, how can session hijacking be avoided is a question that's just come in.
Yeah. I'm not a great fan of kind of session IDs. And essentially, again, it's about relying on things. It's about relying, if we rely on the user providing good data, then we're going to be in trouble. If we rely on the user to provide a good cookie and trust everything in that cookie, we're going to be in trouble. If we rely on the session ID and the URL parameter to be valid, then we're going to be in trouble. So this all needs to be checked in the back end. Now, clearly, things in place like a web app firewall can provide protection and inspection against things like injection and malicious code. But in terms of determining whether a session ID is valid for a particular user, for a particular time, from a particular IP address, that's really something that needs to be handled, I would say, right at the very back end in the code. So again, it's code review, and it's not even, it's not really the code itself, it's kind of business logic, if you like, of that code, and how much we're just blindly trusting that session ID.
Great. I'm going to extend the session by a few minutes. We usually finish at the top of the hour, but there are more questions coming in, and there will be a recording that will be shared with everybody after this, so later this week. So look out for that link by email if you're interested. The next question for you, David, is there a manual blocking technique or use case of a specific IP user session when there is an attack? This individual says, I've seen many automatic options, but not ad hoc. Are you able to give me some insight? Ad hoc blocking of a malicious IP.
Yeah, absolutely. I would have to answer that from a probably biased F5 point of view. I'm trying to think of kind of generic answers, but certainly from an F5 products and solution point of view, we can block IPs arbitrarily. That could be a very manual step. It could be someone logging into an F5 product to apply that block. It can be done programmatically through an API to the F5, so there could be some external system that detects a malicious IP and kind of updates the F5 policy, if you like. Or it could be fully automatic. It could be the F5 product which kind of just learns, whether it's through its integrated IP intelligence database or through some machine learning on the product, which now is a feature of the F5 web app firewalls, to somewhat kind of ad hoc then block those IPs. And again, it's about, that typically is done from a timed point of view. We wouldn't generally block an IP permanently. We might either block it completely or rate limit it for 5 minutes or an hour, for example. Just in case it's a false positive, or in case that IP cycles to a genuine user later on. So I would say, yeah, generically, yes, there are ways of doing that.
And David, here's something around financial services. So how would you make a financial solution secure based on OWASP top 10 after the company acquired the solution without making sure that the OWASP top 10 features were checked during the project phase?
That sounds like a fairly loaded question. The question is, could you repeat the question, Marcus? How is our top 10 used to?
Yeah, so the company's bought the solution and set it up, but hasn't gone through OWASP top 10 to checklist. So how do you sort of retro fit it to stand up to OWASP top 10?
Sure. Okay. Obviously, it's hard to answer the question without knowing what the product is. Depending on the product, it may or may not have some kind of flexibility. Again, with the F5 hat on, there's an awful lot we do out of the box, but with the programmability and the flexibility of the product, you can generally do anything, so you can protect against those unknowns. What I would say in its defense is that the OWASP top 10 is constantly changing. It might not be changing every month or every year, but it does change, and that's clearly why they state themselves, OWASP, that to not use it as some kind of compliance program or regime. It's really just to help raise awareness. So the first thing I would say is, again, try not to take the top 10 too literally. It's really there for education and awareness purposes. Although clearly there are big gaps in this product that aren't, if there are areas in the top 10 that this product can't cover, then that could be an area of concern for sure. But yeah, it's going to be hard to say without knowing the products, to be honest.
All right, and then there's a lot that you could focus on, David. So, what would be the 2 or 3 things that you would recommend that you focus on if you had listened to today's webinar and you're thinking, well, what should I immediately do?
Yeah, there's 2. I might even sneak a cheeky third one in. I mean, I'll kind of go the wrap up, but for me, I can summarize this. The 2 biggest problems we've got, which I think they are top 10 summarizes, their injection attacks and their authentication-based or authorization-based attacks. They're the 2 primary forms of attacks and vulnerabilities that we're seeing. So really, they're the areas we need to focus on: injection and authentication. A lot of that could be mitigated by the kind of third, summary, which is just a patch, to ensure that everything is patched up to date as possible. That is increasingly difficult when we're using, more and more apps, when we're using more and more third-party libraries and hosted scripts and services. That's when things like a web app firewall with virtual patching capabilities can be good, because they can kind of on the fly protect, scrub content. They can protect against vulnerable parameters and so on. But injection and authentication-based attacks will be the 2 big focus. So if you do anything, performing both code-based reviews and kind of process reviews of those 2 forms and methods of attacks.
Got it. And the compliance came up as a question here as well. So, can you actually get OWASP compliant?
No, I mean, so absolutely not. And again, as I mentioned, OWASP then say recommend that you don't use it as a kind of compliance regime or absolute checklist, because things do change. It's very much for awareness. Depending on the industry that you're in, there may well be some kind of existing either legal, framework legislation in place, like GDPR, which pretty much affects everyone, or more specifically like PCI or HIPAA, as we mentioned. So again, try to treat the OWASP less as a kind of checklist of things to kind of go through and tick off, fix this, fix that, fix this one. It's really awareness and changing mindsets. And once we change the mindset to hopefully make everyone from the board right down to developers think about authentication and injection-based attacks, then hopefully the apps are going to be more secure as a whole in the future.
Well, David, there's clearly lots to talk about, and the hour or so that we've had together is just the tip of the iceberg. So I'm sure if anybody has questions, please reach out to your F5 your F5 contacts, and I'm sure they can go into more detail. We will, however, be sharing the link to this recording so that you can get access to that. And I wanted to thank you so much for joining us today. I know there's a lot on, and I know you probably attend lots of webinars, so we appreciate your time. And we do these webinars once a month. The next security-focused one on the 23rd of June, and it'll be focusing on defending your business against fraud and abuse. And I think that's a fantastic and really interesting subject. So look out for the invite to that, and we look forward to seeing you during June. Have a great rest of the day wherever you are, and thanks again for joining. Take care.